Hi everyone, my name is Pradyumn Kejriwal and today we'll discuss the solution to the 27th problem from the CP sheet by TLE Eliminators under the rating of 1400. So let's begin. So here I have a sheet and I'll open this problem. Okay, so it is called news distribution. In some social network, there are n users communicating with each other in m groups of friends. Let us analyze the process of distributing some news between the users. Initially, some user X receives the news from some source, then he or she sends the news to his or her friends. Two users are friends if there is at least one group such that both of them belong to this group. Friends continue sending the news to their friends and so on. The process ends when there is no pair of friends such that one of them knows the news and the other one doesn't know. For each user X, determine what is the number of users that will know the news if initially only the user X starts distributing it. Okay, so they are saying that we have some groups of friends, like there are total n people and there are m groups consisting of some people, right? And all of the people which are in the same group, they are friends. Okay, and one person may be in multiple groups. Okay, right? So what will happen is, like when we give some information to a person, let's say, then he will spread it to all of his friends, right? Natural human tendency. So he will spread this information to all of his friends, that is all of his group mates. So in any of the groups which he is in, he will spread it to all of those groups, right? Then all of those friends, they will receive the information and they will spread it to their friends who don't know already. Like, see, of course, if he is his friend, then he is his friend also, but both of them already know, so this person won't again tell him. But yeah, so this person will go ahead and tell his other friends, which may be from other groups as well, right? So this way the information will spread. So in this problem we have to determine that for each value of x, like we have to answer the problem for each value of x. And what is the question? The question is that if we start with x, like, or if we give the information to just x, then how many people will know finally? How many people will know? Okay, so this will be best understood by a sample. So I will just use this sample because it is very convenient. Okay, so let's see if I can copy this. Okay, yeah, nice. So what I am saying is that we have here the sample test case. So 7 means that there are total 7 people, 5 means there are 5 groups, right? So these 5 are the groups. Okay, so the first group has 3 members and there are 2, 5 and 4, right? So 2, 5 and 4 is one group. Then second group has no members. Then third group has 1 and 2 in it, and the fourth group has just 1 in it. So it is a pretty lonely group. And finally this last group contains 6 and 7. So let's say if I want to answer this question for 1. Okay, so like if I set x equal to 1, that means if I give the information to just 1, then where will it travel? Like to how many people will it reach? So 1 is part of 2 groups, right? This group and this group. So in this group there is only him, so there is no other friend. But in this group there is 2 also. So from 1 it will spread to 2, right? Then where is 2? So 2 is in this group and this group. So in this group 1 already knows, right? But from this group 5 and 4 are there who don't know. So 2 will tell to 5 and 4, right? And 5 and 4 are not there in any other group. So this is how it ends. Like everyone knows who can know. So there are total 4 people who know this information. So the answer for x equal to 1 is 4, right? and we have to print the answer for every person x, like for every starting number from 1 to n, that is x from 1 to n, we have to print that finally how many people will know the information, right? So that's the problem. So I'll let you guys solve this, but yeah, before that, the constraints here are that the number of members, like the number of people and the number of groups, they are both up to 5v5, and also the total value of ki, like this ki is the number of people in the ith group, right? So the total number of people in all the groups will be less than equal to 5v5. Okay, so since your n and m and summation of ki, they are all up to 5v5, 5 into 10 to the power 5, you can hope to solve it in O of n plus m, or like linear or logarithmic, like n into log m or something. These complexities will work. Okay, so just try to solve this in those complexities. Alright, so I am just giving you some time to pause the video and try it by yourself. Okay, so I'm assuming that you have tried this one by yourself and you want the solution. So guys, full disclaimer, if you don't know anything about graphs, then I think you should study graphs before attempting this problem, especially DSU. Okay, so I will use DSU in this problem and I'll assume that you have experience with that. Okay, so alright, what is this problem? This problem has some groups, right? Like let's say there is one group like this, like multiple people are there in that group. Then there is one group like this. So this person is there in both of these groups, and let's say there is one group again like something like this, let's say. So these two people are there in this group. Now if I give some information to this person, then it will spread to all of these four people because they are in same group, right? And then it will spread to this person because these two people will tell him, and then it will spread to all of these people because they are in the same group as this one, right? And let's say I had one more group like this. Then if I give information to this person, then these two people won't get the information because they are not connected to it at all, right? So this kind of just seems like a graph problem with some connectivity queries, right? Or connected components thing. So like I'll show you how to imagine this like a graph. Okay, so let's say again I'll paste something here. Yeah, so the test case is this. So here there are 5 groups, right? 2, 5 and 4, they are in same group. So what I'll do is I'll make a graph containing n nodes. Okay, so one node for each person. Okay, so there are 7 nodes in my graph for this sample test case, and also I will add an edge between two people if they are friends. Okay, so let's say this first group has 2, 5, 4. That means 2, 5 and 4, they are all friends. Alright, so I will add the edge between all 3 of them. Then this group has no people, so it doesn't matter. Then this group has 1 and 2, so 1 and 2 are friends, so I will add this edge between 1 and 2. Then this is just 1, doesn't matter. And 6 and 7, so I will add the edge between 6 and 7. And there is one node 3 also, it doesn't have any edges, right? So I have made this graph. Okay, and it's like which pair of peoples are friends, right? And let's say if I give someone the information, then obviously all of the people in the same component as that person will get that information, right? So like this component size is 4, correct? So if I give the information to any of the persons in this component, then they will like all of them will get the information. So the answer for any nodes like 1, 2, 4 and 5 is 4, right? So you can verify it as well, that for nodes 1, 2 and 4, 5, the answer is 4. Then this component has 6 and 7 in it. So if I give the answer, if I give the information to either 6 or 7, 2 people will receive it, right? So the answer for 6 and 7 is 2. And finally this component is there 3. So since there is only one person in this component, he will get the information. So the answer for 3 is 1. So this problem is basically that simple. Like, you just have to make the graph and find out that in each connected component how many nodes are there. And as you may know, that can be easily done by DSU. So if in DSU, you might know that either you can rank by size, right? Rank by size, that is, you will keep track of the component's size, or you can do rank by height, or rank by rank also it is called. So if you use rank by size, then automatically you will be keeping track of the size of each component, right? So you can just use that, and for every node just check that what will be its size. Like, just make this graph right here, and then just check that for every node what will be its size, right? But there is one caveat in this problem. Like, there is one problem in this, my solution. What is the problem? I said that in my graph I will make an edge between every pair of people who are friends. So like, in this group, this 2, 5 and 4 are friends, right? So I added an edge between 2, 4, 2, 5 and 5, 4, right? So I added an edge between every pair of people. But that might give some problems. Why? Because let's say I have a group whose size is very big. Like, let's say I have a group whose size k is 10 to the power 5. Okay, and that is allowed, right? That is possible, because if let's say n is equal to 10 to the power 5, then it might happen that every person is in the same group. So this is possible. So in that case, if I draw an edge between all the pairs of users in the same group, then I'll have to draw kc2 edges, that is k into k minus 1 by 2. That means order of k square edges I'll have to draw, right? But since this k can be up to 5e5 in fact, so this order of k square edges I cannot draw. So can I modify my graph in such a way that the connectedness of components doesn't change, but I don't have O of n square edges or O of k square edges basically. So I should have less number of edges, but like, the connectivity should not be hampered, right? So instead of like making an edge between all pairs of friends, can I do something else? So yes, I can do. Like, what I propose is that, see, what your aim is that these 3 people must be in the same component. Okay, it is not necessary that you should add an edge between every pair of these. Like, if these 3 you ensure that they are in same component, then of course if one of them gets the news, then the other one will definitely get. That's the entire point of our graph, right? So if you just need to ensure that every node in your graph, I mean every node in this group has to be in the same component, just make an edge between, like, let's say the first and second, and the first and third, and the first and fourth if there is something. So basically just add an edge between first, second, first and third, first and fourth, like essentially between first and every node. So if the size of component is k, then you will be adding only k minus 1 edges, that is order of k edges sorry, instead of order of k square edges. So the problem that we encountered has been solved this way. So how will this graph, how will it change? So with 2, 5, 4, I will only add an edge between 2, 5 and 2, 4. So there won't be any edge between this 5 and 4. Okay, so you can see this edge is not there, but still this entire thing is one component right here. Why? Because we ensured that all the people in this group are in the same component. right? They are still in the same component, so it doesn't matter, the answer doesn't change that way. So just make this graph and use DSU, and you will get the size for all the components, and for every node just find its component and print its size, right? So that should be pretty clear for the solution, and I'll simply show the code. Okay, so here in the code I have first of all the fast IO, of course, and solve function. And in the solve function I have int nm, scene nm, and yeah, I have these DSU code, that is the find and join functions, that is find set and union sets if you may, and I have the parent array and the size array, right? So I'll resize the parent array, like I'll initialize it where parent of I equal to I, because initially every node, like initially there are no edges, right? And size of every component is also 1, so size dot resize n comma 1. Then I'll iterate over all the groups. So for int I equal to 0, I less than I plus plus, I'll take the size of the group, and also I'll take the first element. Like, okay, I'll just take the input of the group and just add the required edges, that is just add the edges between the first node and all the other nodes. So I will take the input in the first, and I'll make it 0 indexed, and then I will just iterate from 1 to k minus 1 and take all the other nodes as input. So int a, c in a minus minus, and I'll join all the other nodes with the first node. So I'll basically add an edge between those nodes, right? So this is the entire code for making a graph, right? And finally, just for all the nodes, what you will do is print the size of the component in which I is there. So if I want to print the answer for I will find that in which component I lies and just print its size, right? So that's the entire thing, and I'll just run through the code of DSU as well. So this find first checks if a is equal to parent of a. If it is, then of course a is the component, so return a. Otherwise it will find the parent of a recursively, like it will call the find function for parent of a and return that. And also it uses path compression, so it will just set the parent of a as that thing also. And how join works is I'll call a equal to find a, b equal to find b, and also if size of a is less than size of b, I'll swap a and b. So I'm joining the smaller one into the larger one. So parent of b equal to a and size of a plus equals to size of b, right? So that's how I'm keeping a track of the sizes. Like when I'm merging b into a, of course the size of a increases by size of b, right? So this was the entire code, and the complexity of this would be just, this is the input, right? So this is just size of input into this join complexity. So that is alpha of n, that is the TC of DSU, right? Inverse Ackermann function of n multiplied by summation of ki, right? Like this is the input, that is the number of nodes in our input, and this is just n into alpha of I. So alpha n into summation of ki plus alpha n into n. So this is the complexity, time complexity of this approach, and the space complexity is just O of n, because we are storing the parent and size arrays of length n each, right? So I hope you understood this, and thanks for watching.